Now that we know some of the basics of logarithms, we want to talk about laws of logarithms, which are the rules that we use to manipulate different kinds of logarithmic expressions and equations. We've talked about the general log rule. We already know that one. The first one we want to talk about in this video is the product rule. So when we're dealing with logarithms, the product rule tells us that if we have log base a of the product of two expressions, so x and y multiplied together, that's the same thing as log base a of x, the first value, plus log base a of y. And one thing we want to keep in mind with all of these rules, we're going to talk about a few more in this video, is that these rules work both ways. So if we have this expression on the left, we can use the product rule to rewrite it as the expression on the right. But in the same way, if we have this expression on the right-hand side, we can use the product rule to condense it into this version on the left. And which way we go just depends on what we've been given and what best simplifies the expression. So for instance, if we want to look at an example with the product rule, we could take the example log base 4 of 64 plus log base 4 of 16. If we're given this expression and we're asked to simplify it, we want to realize that we have two logs added together with the same bases. They both have a base 4, and that matches the right-hand side of this product rule formula. We have two logs, both with the same base a, and just two different arguments, x and y. So we could apply the product rule to this expression and condense this expression into what we have on the left-hand side. So using the formula, we can say that this expression on the right is equal to log base a, so we keep the same log with the base 4. And then for the argument, we multiply the two arguments together. So we multiply 64 by 16. 64 times 16 is 1024. So we get log base 4 of 1024. And then we could simply leave the logarithm this way. A lot of times when we're given a problem like this one, we're just asked to write this expression as a single logarithm. So we've already accomplished that. We've written this as a single logarithm. But then we could bring in the general log rule, for instance, apply it to what we have left over, and try to get a real number answer or a real value for this log. So if we apply the general log rule, we match up this log base a of y equals x to what we have and convert it into the exponential form a to the x equals y. So when we do that, we take the base a, which we know is 4, we raise that to the x, and we assume here for a second that this is set equal to x, and then we set that equal to y, which is the argument of the logarithm, so 1024. And then from here, we simply equate bases on both sides. We know that 1024 is the same as 4 to the 5th power, so we can rewrite this as 4 to the x is equal to 4 to the 5th power, and because the bases are equal to one another, that means the exponents have to be equal to one another, so we get x equals 5, and what that tells us then is that this value right here, log base 4 of 1024, that's equal to 5, which also tells us that log base 4 of 64 plus log base 4 of 16, that is also equal to 5, since this simplified version is exactly the same as the version that we started with. So we found that this expression we were given has a value equal to 5 by using the product rule and the general log rule together. And that's the one other thing that we want to keep in mind. With all of the rules we're going to go through in this video, you can combine multiple rules together to simplify a logarithmic expression. So if you want to use the product rule and the general log rule together, you can. Whatever rules help you to simplify the expression, you can go ahead and combine any set of rules that you want to. Let's look at the next rule. We have two more. This next one here is the quotient rule. And the quotient rule tells us that when we have log base a of x divided by y, so x over y is the argument of the log, that's the same as log base a of x minus log base a of y. In other words, we take the numerator of the argument, that becomes the argument of the first log, then we always have subtraction here, and we take the denominator of the argument of this original log, and that becomes the argument of this second log that appears after the subtraction. And same thing as with the product rule. Even if we have this expression on the right-hand side, we can use the quotient rule to condense that expression down into the left-hand side of this quotient rule formula. So if we wanted to look at an example of this, let's say we're given log base 2 of 4 minus log base 2 of 2. And we're asked to write this as one logarithm and then find a single real number value for the expression. So we recognize here that we have subtraction and that we have two logs with the same base. They're both log base 2. So we know that that matches the right-hand side of the quotient rule formula. We'll use that to condense the expression into one logarithm. So when we condense it into one, we get log base 2. And then for the argument, we take the argument on the first log, 4, and divide that by the argument in the second log, 2. 4 divided by 2 is 2, so now we have log base 2 of 2, and we've rewritten the expression as one logarithm. Then if we want to find a real number value for this log, we can again use the general log rule. So let's set this equal to x, and then we can convert, and we can say 2, the base, raised to the x power, is equal to the argument. And here what we realize is that 2 on the right-hand side is the same as 2 to the 1. So because the bases are equal, the exponents also have to be equal, and we can say x equals 1. And then what we know is that the original expression we were given, log base 2 of 4 minus log base 2 of 2, that's equal to 1. We also know that log base 2 of 2 is equal to 1. The last rule we want to look at is the power rule. And the power rule tells us that when we have log base a of x to the n, so x to the n is the argument, this exponent of n is inside the argument of the log function. It's part of the argument. That's the same thing as n times log base a of x. In other words, we take this exponent of n and we move it out in front of the logarithm. That's what the power rule tells us that we can do. We can take that exponent and move it out in front. Or, going the other way, if you have this value in front of the logarithm, you could take it into the argument and make it an exponent on the argument of the logarithm. So if we look at an example, let's say we have 2 times log base 5 of 10 minus log base 5 of 4. And we want to try to simplify this as much as we can. When we first look at this, we notice that we might be able to use power rule for logs because we have this 2 multiplied by log base 5 of 10. We have the 2 out in front as a coefficient. And we know from power rule that we can pull that in here and make that the exponent on the argument of the 10. So if we try that, we get log base 5 of 10 to the power of 2 minus log base 5 of 4. If we continue to simplify, 10 squared we know is 100. So log base 5 of 100 minus log base 5 of 4. Well, now what we realize is that we have the right-hand side of quotient rule. We have 2 logs, both with the same base of 5, and we have subtraction in the middle. So we can use quotient rule to condense the logarithm and write this as log base 5 of 100, the first argument, divided by 4, the second argument. 100 divided by 4 is 25, so we can say log base 5 of 25. And then from here, we can use the general log rule to write this in exponential form and try to get a real number value for the answer. So if we convert this using the general log rule, we take the base of 5, so we say 5 to the x, we don't know the result of this, is equal to the argument 25. Well, we probably know just by looking at this that 5 squared is 25, but if we weren't sure, we could rewrite 25 with the base of 5. So 25 we know is 5 squared, so if we say 5 to the x equals 5 squared, rewriting the 25 as 5 to the 2. The bases are now the same, which means the exponents have to be equal. So we get the exponent of x equals the exponent of 2, or x equals 2. And what that tells us then is that log base 5 of 25 is equal to 2, or more importantly, that the value of our original expression, this whole thing, 2 log base 5 of 10 minus log base 5 of 4, actually has a value of 2. And we found that using a combination of the power rule, the quotient rule, and the general log rule to get from this complicated logarithmic expression all the way down to the actual value of it, which is 2.